Alright, hello, this is Scholar Sharp doing some math. Today in number 2, we're going to be looking at properties of logarithms. So let's start off with some identity problems. And I'm going to change A here into B. So every time you see a because I just like to use the word base when talking about log base B. But anyways, just remember that anything to the 0th power is 1, and anything to the first power is itself. 7 to the first power is 7. And along with logarithms, log base b of 1 equals 0. So for example, log base 5 of 1 will always equal 0. Log base 3 of 3 equals 3. Or 1, sorry. Because it's asking what power 3 to what power is 3, and that's what. So whenever you have log base b of b, or log base a of a, they'll cancel each other out, and you're left with 1. Here we go. Inverse properties. So log base a of a to the x equals x. So if I have log base 7 of 7 to the x, or sorry, to the 3, then that'll give me 3. And the same thing here, 7 to the log of 7 of 5. So 7 to the exponent log base 7 of 5 is 5. So what I'm saying is, if you have a base and you take it to the log of that base power, those cancel and you're left with the 5 there. Product rule. Alright. So let's say we have log base 2 of 4 times 3. That's the same thing as log base 2 of 4 plus log base 2 of 3. So you can expand these, or you can condense them. So if I had log base 2 of 4 plus log base 2 of 3, that is the same thing as log base 2 of 4 times 3, which is 12. Okay. Quotient rule. Same thing. If you have a number divided by a number, so log base, 3 of 7 over 5, that is the same thing as log base 3 of 7 minus log base 3 of 5. So you can expand them, and you can also condense them. Let's say log base 6 of 2 minus log base 6 of 7 is the same thing as log base 6 of 2 over 7. Power property of, or exponent rule. So log base b of m to the n equals n times the log base b of n. So they're taking this n power, and you can move it outside. So if I had log base 2 of 5 to the 3rd, that is the same thing. Okay, just moving the 3 outside. 3 times the log of base 2 to the 5, or to base 2 of 5. Okay, and then vice versa. If you see this outside, 6 times log base 2 of 7, that is the same thing as log base 2 of 7 to the 6th. Alright, change of base. So log base 7 of 5. We can change this to log of 5. Remember, log of 5 is just log base 10 over log base 7. And we use these so we can actually use our calculator, because if you notice in your calculator, you only see log base 10. And natural log, well, and natural log base e. Log base e. And this also works on natural logs. Alright. Okay, so this, a lot of the times, you know, we're just going to use a calculator. But if we know the value of something, we can use our rules from above to solve these. So part A, log base 4 of 3 over 7. That is the same thing as log base 4 of 3 minus log base 4 of 7. Okay. And since we know what log base 4 of 7 is and log base 4 of 3, 1.40, oh, sorry. This one is log base 4 of 3, so 0.792 minus 1.404, and that'll give us a calculator problem anyways. 0.792 minus 1.404, negative 0.612. Okay, let's go ahead and do C. So we know 49 is also 7 times 7. So this is log base 4 of 7 plus log base 4 of 7, which is the same thing as 2 times 1.404. So 2.808. Part B. So log base 4 of 21, again, that's log base 4 of 7 plus log base 4 of 3. So we're going to add the two together. So 1.404 plus 0.792. I'm going to go ahead and skip the calculation there. Log base 4 of 12. Now this is a tricky one. But we should know that log base 4, so 12 could be broken down into 3 and 4. But what is log base 4 of 4? That is 1. And we know what log base 4 of 3 is, 0.792. So we add them together to get 1.792. Alright, expand log base 6 of this mess. So things that get multiplied together get added. So we have log base 6 plus log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. 6 go down here. But there's only one more thing I can do, is move this to the front here, because that was our, where is it? Our power property or exponent rule. Okay. So the completed form of this is log base 6 of 5 plus 3 times the log base 6 of x minus log base 6 of y. Okay, now we're going to condense. So we know it's going to be natural log. Natural log of 4 plus 3 times the natural log of 3. Okay, so this one here, let's go back over here. Remember, we can move the exponent, we can move this front number to the exponent slot. So this will become ln of 3 cubed, which is 3 times 3 is 9, times 3 is 27. So this will be ln of 27. Okay. Now when we have ln of 4 plus ln of 27, we multiply them together. 4 times 27 is 108. And then we have subtraction, so we put division sign of 12. And then we can reduce this to ln of 9. 108 divided by 12 is 9. Okay, evaluate using the base change. So log base 8 of 3. So this is purely a calculator problem. So if you have a fancy calculator, you can put the base in there. A lot of your cheaper calculators, you can only use log base 10. So this is how you would do it. You would put in your calculator log of 3 over log of 8. And then you would use calculator. And then they came up with this nice little sound intensity formula. Basically how intense, kind of like how loud something is. Loudness in decibels. So loudness right here in decibels. Yeah. Hopefully this helps you out. Have a good day.